Okay, so home stretch, last little set of problems. Let's take a look at solving some problems with uncommon bases. So in problems 13 and 14, those problems have totally different bases. And I wanted to look at that because sometimes I gravitate towards these problems right here. Notice where there's a variable in both exponents. And I sometimes don't take the time to look at some of those problems where it's maybe technically even a little bit easier, but then I've had students get very confused. So we're going to just look at those last couple of problems here. Question 13 and 14 go as follows. Now, when we have this story like this, the first thing I would do is I would say, well, this little piece of the story is kind of an ugly piece. This exponential seems to be problematic to me. So the first thing I chose to do is I divided both sides by 5. That, again, made this a little bit uglier, but it's not really that big of a deal. And so, but I still have a problem that has a variable that's an exponent. So I take the log of both sides. Again, it could be a common log. I just personally gravitate towards natural logs. Now, as such, I'm going to do a quick distributive property, 2 natural logs of 4 minus 3x natural logs of 4. I need to get the x part by itself, so I should move this 2 natural logs of 4 to the other side. And then, of course, all that I have left to do is take whatever this thing is right here, and I need to divide it by a -3 and a natural log of 4. And this is a good answer, but of course, we can plug it into a calculator and get an approximation. This is a great answer. This is an okay answer. I normally would probably leave it right here, or in fact, even better yet, I might leave this 1.8 as the fraction 9/5, which if you look above here, we could have called that 9/5. Now, number 14 is actually technically a harder problem because we're in a situation where we don't have just one side with an exponent variable, we have both. So when we take the log of both sides, that allows those exponents to come in front by property number 3. I don't like all these parentheses, so I did a quick distributive property. I moved all of the x's around so that all of the x's, notice there's an x on both sides. I moved the x's to the same side together. This one doesn't have an x, so I moved it to the other side. So notice I've grouped it because now that these are all having the x's together, I could factor an x out and then a quick division. Now, I know that most students are going to want to go ahead and get that as a decimal, but that's actually the best answer. And I've already kind of shown what we can do here. We can take a problem like this, and again, I'm going to show this because it is tricky sometimes to make sure you're plugging into the calculator right. I'm going to have 2 natural logs of 4. Notice I had to close the parentheses on the 4 on my calculator. Some of yours don't. Minus natural log of 11, and I need to close not only the 11, but the entire, oh, darn it, 2 natural logs of 4, accidentally hit a button, plus natural log of 11, close, close. The first close closes the 11, the second close closes the parentheses that I forgot to put back in. Now, I'm going to divide that by parentheses, log of 11, minus 7 logs of 4, close, close. First close closes the natural log, and the second one closes the entire denominator. And I'm going to store that as A or B or C or whatever the heck you want to call it. But if I have done this right and I take 11 and I raise it to the A minus 1 power, that was the original problem. Hopefully I get the same if I take 4 and I raise it to the 7A plus 2 power. And I can honestly say you've seen me make mistakes in these videos already. Sometimes I do make mistakes on those, so it's not just magic that that happens. Okay, so moving on to question 15, just 2 problems to go in the whole review. It's been kind of a marathon, but we're going to talk about an inverse, and this is kind of an important one to me because I emphasized early on that a logarithm and an exponent are inverses of each other. So if f is a logarithm, then f inverse has to be an exponential. If the base of the log is 2, so the base of the exponential has to be 2 as well. So the first thing that we do is I took this problem right here and I switched x and y. So instead of calling it y equals the log base 2 of this, I said x is the log base 2 of y. So this is already technically an inverse, but the second part of inverses is we want to try, if we at all can, to get the y by itself. So the property of logarithm says that the base of, okay, so the first thing I did is I guess I got to kick that 2 to the other side. But then the property says I'm going to take 2 and I'm going to raise it to that x plus 2 power. That's the properties, that's the definition of log, again, going right back to it. And then the only thing we have left to do is to move that 3. Now, that being stated, there is a little bit that we want to talk about in terms of domain and range. In terms of the domain of a log, you can only take the log of positive numbers. So x has to be above -3 or it won't be positive. And the range of a log is actually all reals. It's been a little while since we've talked about it, but the general way that a log looks like, the graph of y equals log x is a graph that looks like this. And it's a strange looking graph, I know, when people aren't used to it, but it's really the same graph as this graph, e to the x, or the natural log, or maybe 6 to the x. These are literally the same graph, just reflected across a diagonal line. So the inverse is just going to take those original values and flop them. And our final question says, I've got some exponential, a times b to the x, that's what we know, where if I plug in 3, I get 8, and if I plug in 5, I get 72. So let's just go for it. If x is 3, that would mean b to the third times a is 8. So this is the value that I showed. And then if I use the 572, that's another one. So I'm, again, just applying, I'm going to minimize something out of my way. So I just applied what the actual definition of an exponential function looks like. Now, what's kind of cool, and you can do this, you did this back in Algebra 2 sometimes when you multiplied things together or added down. I'm going to divide these things down, and I have 9 as b squared. And so that's pretty awesome because that makes b technically plus or minus 3 from this moment, but one of our rules says that in an exponential, the base has to be a positive number. So I know b has to be 3. So if b is known to be 3, a times 3 to the x, and the only thing I have left to do is maybe use one of the numbers, and it doesn't matter which number I used, but I went ahead and I plugged in 3 for x, as this says right here, and I plugged in 8 for y right there. And if you go through the math, 3 to the third is 27. Divide, and all of a sudden now I know what b is, I know what a is, and I have finished my exponential story, and the marathon that is the final exam review is complete, and it's been a joy, if not a little bit exhausting. See you in class. Bye.